Okay, because function in JavaScript, they are first class citizens. That means that they are treated as they were functions. Let's repeat what we say. Classes are blueprints that contains, in this case, properties and method. We use it in order to construct other data types that we don't have it. Then we have it and they are repetitive. Allow us to reduce the code because we don't have to create those objects all the time. We just pass some information and these factories give us back those objects. That is why what vectors say, oh, it's allow us to create other objects and don't repeat ourselves. It's the same as a factory. You take everything, you take all the elements, you pass it into the factory, and the factory give you one new element. Example, you get all the irons and all the thing, you pass it through the building factory that create cars, right? It's the same idea. You give some elements and you get back one product. That's everything, right? For example, in a car, you the let me just go here. Just say it. Car factory. Yeah. Yeah. Process maybe. Uh-huh. And here, right? You pass some information and all the different steps are passing inside, and at the very end, you have the car completely right there. And this is the same idea what we have it. We have this, all this part here is what you don't see it. That is like the constructor, the method, the applying everything that you do here, and you just pass the information that you have the information, and at the very end, you have a very beautiful new function. It can be in this case one store, right? And that the store has everything. I think that this is the most common example that you see it. Okay? That is the idea. And this one is called design pattern factory. Is called this one. And this is a very nice thing that you have. And you will just see it. That is here. We have the class. We have, I think that here must be some a TypeScript. TypeScript will be absolutely the same. You have the class is created. Here, this doesn't exist, honestly. This abstract and public, everything is the same. Then you have the different methods. And here you have it. The class, create, implement products, and you are doing this thing. You can just go and read it. The idea is not to go over this one. It's which language it is. Okay. And then you have it. That is the idea. There is no more. By the way, if you want to learn more about design pattern, you can go here and go. It's so cool, this website with the creational pattern, factory, abstracts, builder, single. And this one that you see here, this prototype, this is the real one, the how JavaScript works. JavaScript tends to work with the design pattern that is prototyping is very similar to factories, but with the small. You are just creating copies of the elements that are created. Okay. Yes.
Excuse me. So is it a class equal to factories? The same?
No. The factory is the name or the technique for saying like this. That is the technique. But the class is how you implement that one. Because if you see this prototyping here, you will also have a class. All of the is the way that you are doing it. The idea of the factory is like this, that you enter some, for example, you enter some so raw material and the factory create you the objects. That is the idea based on this one. All this, okay, the first thing that I have to do is define what is a design pattern. A design pattern is a process or is a well-defined solution for a problem. That is the thing. It's a solution for a problem. Which is the problem that we have it? As a vector say, sometimes we have one object that is repeating and repeating and repeating all the time. Then, in order to solve that problem, what we do? We create this blueprint, and this blueprint is a creational, is a class that create new objects. You give some information that is the basis. For example, let's say that we have a class that is called student. You pass the name and other information, and then give you one object. Into that object, you have you have the properties, and you also have the method inside of it. That is what we have. Let's say it like, for example, we have the const array, and you have the array, the const array 2, and here we have it 2, 3, half. Both are inheriting, or both use the same idea of when we are using this bracket is creating one object, and inside that object, for example, I have the different methods. There, for example, that could be reduce. Reduce. Both of them has the same method. But what is the difference between one and the other one? The properties that they have inside, or the information that they have it, but they are created in the same way. That is what you have. Here, for example, you can have something like let's say you have the class array, and you say new array, and you are passing this one. Just because JavaScript, in this case, this is so common that you don't call the constructor of the array. You just put the bracket and they are created. But think about this one. You are creating here one object, the type array, with this information. And here you are creating an object of the type array with this information that you have here. And this, what is doing, and is creating you an object, this one, that contain these properties and all the methods inherent, or they are coming from the parent array. This is your factory that you are calling over. There is not, the factory method is not a class. It's just a simple solution, and we just call it in that way. If you pass data and you receive an object back, that is called a factory.
Okay, means when we are creating the instance of that instance, right?
Exactly. Nothing more. And there are different design patterns, as I said here, that you can use it. And you can read it a little bit. And if you are interested in one of these, we can just talk about it later. You have it. And there are different adapter, bridget. Okay. And all of those is just how you, for example, behavioral. I like it, this one. One of the most, this one, the observer. The observer means when you trigger one action after something happens. Sometimes you have this function that when this function get called, call this and this and this and this and this another function inside. This is what we call it observer, because the observer is waiting for one action to be performed, and when that action happens, you perform other option. They are just design solution for different problems that you have. And you can go over there. If not, I will not stop talking about it. Okay. But the idea is that we have it. We have the classes, and today we will create one class that is called a linked list. linked list. Let's go here. First, we will define it. What is a linked list? Then we will compare it, the linked list, with the arrays that they are the most common that we have it. And we will implement the insertion, removal, a transversal method or a single list, like adding, removal, creating all these different methods that we have it so far. And let's start thinking, what are the problems that we face it when we are using arrays? Using arrays. Arrays adding to beginning. What happened to add something to the position 0 in an array? What is the big O notation of that operation? Can someone help me with that? What happened when you add one element into this? Yes, I am.
So all of elements will move to the next position, and it's all. I'm not good in this thing.
O-N.
Oh, yeah.
Thank you so much, Yolanda. Yes, it's big
Yeah,
O-N.
I mean, Vector said the magic word. They are gonna move. So, yeah.
Why n? I thought it's only we have only one element you wanna put, and
that is a very nice thing. Let's just review it because we have it. Oh, Joanna will explain me right now why they are N. Someone can tell me why is big O N, like when we are adding to the beginning?
Excuse me, what was the question, Mario?
What is the problem that we have it adding one new element into an array in the position 0 at the beginning of the array?
Okay. Yeah, we have. It has to reassign all the indexes for all the values.
Exactly.
It's moving. Yeah.
Yeah. In that one, for example, we have position 0, 1, 2, and so on, right? 3 and 4. Okay. If I want to add something here at the beginning, then I will have to move all of this guy here. And now this, then I will have to do this, for example, here. And I will have to move it. Okay, this is position this is position 1, something, something, something. And all of them in this case are moving one position. Why? Because the array is in this case solid. I mean, it's a block of the information. Then you are just moving to the next space into your memory. And that is one inconvenience. But exists the way that we can add, that we can create a new type of data structure that allows to add to beginning without moving all the other elements. Okay. Every time when we are talking about objects, we have objects. Let's say it, and let me just go over here. I will plus this one. One question. Let's say that we have a cons object, and this object is one element, and let's say here is a is 1, and then I say cons object 2, and I say that is also object What is going to happen if, for example, I say console.log OVG equals to OVG2? What
False.
is going to false? Everybody like that? We all agree with the vector?
I think it's going to be true.
Why true and why false? I mean, that let's discuss it because we have to solve this problem before pressing run.
Yeah, let me. Yeah, because it's referring in the same place in the address. Object one created. It has the address of the beginning of this, and it has a reference.
Vector, you wanted to say something?
I thought they are still in the different places. I thought like object one and object two has same properties, but they're in the different places. But yeah, Kai is right. Yeah.
And this one will give you one thing before everything. This one is a reference. The good thing, what it was very interesting. What's very interesting? This one. What happened when we create one object or when we create one variable? What happened in the computer itself? What happened? What happened when we create a variable or an object in JavaScript? Let's talk it in JavaScript. What happened? What happened in this case? Yes, Ian, you wanted to tell me something? Ian? Okay, Vector? Yeah, go.
Maybe we are putting some information in some space which contains all informations.
Okay, we add
New info.
some new info. We add some. We have new info. New information. We add new information.
So I don't know what they are contains. I don't know what place. Just some memory. What's
Memory. Okay, memory. Anyone else? What happens when we create a function? We create, in this case, an object, or we create a constant or whatever. You suppose like we are doing it all the time. Yeah.
Yeah, we are. Yeah, we're kind of allocating the space to store this variable's value. And
We allocate a space to store
it's
something.
memory, yeah.
Allocate space of memory. Okay, we allocate the space of memory, and that allocate this space of memory that allow you to save that thing. Okay. And we allocate one space of memory that is here. That means that this one, and I would like that for today, if this one is saving one reference to a space on your disk that has the information. Okay, that is a reference. Let's say it that the reference is XM0134. Just for saying something, that is the name of the space of memory that it was allocated here. Then what you have here in object 2 is a reference to a reference. Is a reference to a reference. That means that if you see it here, the only thing that I am saying, if I just do it different, console log, this reference is equal to this reference. That is why this is true, because this one basically is called a vector. A vector, think about like a Google Maps, is a point in your memory where this information is saved. That is what is in reality one variable or whatever you have there. It's a reference where is something saved. Now, this one is another reference. This is another reference. And then what you have here is you say, hey, go to this position and here go to this specifically position itself when you were saying that information. That makes sense now?
Yeah. So where is this memory? Where? I mean, in some database or in our.
It could be in your RAM. Okay, first thing, I don't know directly. Could be your RAM or can be your browser, can be your hard disk. The system will allocate it as is working when you have a space. And when you still have a space, the system will just find a way to add it.
Okay.
Mm-hmm.
The
It
object
is
object will send us to object, and he will send us to the right. Just 2 steps. Okay.
in one very interesting thing, like nobody asking me is, hey, if we are allocated information, how this information get deleted later, right? If not, we have a limited space. I would like you to read about like a garbage.
Will not be
Garbage.
deleted. It's gonna stay there until it's occupied by others.
Yeah, but I would like you to read about garbage collector in JavaScript. In next class, you explain me how it works, because this one doesn't exist in other language. For example, if you are working in C or other languages, you have to do it yourself. JavaScript is doing it. Just as a reference, I would like you to read about it if you want it. It's not about today class, but it's very interesting to know it. Then this is why the objects are always the same. And you will see soon why I am paying too much attention to this kind of thing. Now, let's say that I am creating one object, and this object is called a student. Let me just say that this is it will be like a, for example, I saw that. I saw that. And this one, here it has to address, and then this address, there is another object, like for example, that is called exact. And here is another object that is saying, for example, street, and this street has something that it was number 5. And inside we have name of this one, and inside the name will be something like a main name. Here I forgot to add one comma. Sorry, main. In this case is France. Okay, this is an object, right? This is what we have. We have an object. We have an object, and this object that we have it over here, it has different property. Can someone tell me how you access to this main? How you will access to that element? I want just to console log the main street. The main street name. Yes?
Before we just jumped by keys.
How?
That like it, but it's very bad idea.
Do just Izada dot
Yeah, that, but
dot
Oh,
exact
ah,
dot not address exact. No, it's inside the address, right? Address.
yeah. Is
Okay, yeah,
address
address dot
exact.
exact dot street
Mm,
dot
mm,
no.
yeah, like this.
Ah,
Number, oh my goodness.
okay. That is the idea, right? That we are getting it and it's saying, okay, this stuff is completely useless that we were having over there. And so on. So, oh, okay, cool, right? When we have an object, this object goes inside another object and another object and another object and another object that we are having here. Like a property, 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 property. This is one idea that we have it. Now we know how to access into an object. Now, let's try to make this idea of adding elements into a, let's say that today we are in the bank. We are in the bank. And in this in the bank, you have a list of elements, right? All the time adding it into the list. Someone arrives and get into that list and get into that list and get into that list and get into that list. Every time that we remove one from the line, everybody moves. That means that you are creating, in this case, for example, you have I was like a Kunde. German is getting, but let's say that we have client 1, and then you have client 2, then you are having client 3, then you have a client 4, and so on, right? Okay. My question is, when you have this inconvenience about client, when a new client arrives, we have to add it to the client 0, right? Client 0, client 0, client 0. And then this client 0 go to the beginning. If we are using, for example, an array, we will have to move all the elements to the beginning. Okay, but removing is so cool, right? Because we don't have to do anything. But every time that one new customer is arriving, all the customers were moving. And this one is very common when we are having problems. Usually you have process, and those processes are adding one after another one. Let's think like you have to create, or you have to pass this process into a new, you have a new information, and this new information had to be passed into a new process. And sometimes you have to be waiting one by one. And then if we are using an array, that is giving you one inconvenience. This kind of problems can be solved with one linked list. Linked list is theoretical, say node, it's called a node, that is linked to the next node. Every time, every node is equal one object that has a value, and one something that is called next. And this next can be null or another object. Can be null of another object. And let me just create a linked list, a simple list. And this list will just have it here. Let's say it that we have value, and this value will be 4. Next, we'll have another object, and this object will have another value, 5, and we will have next, that it will be another object, that it will have another value, let's say 8, and it will have another object or another node that simple null. My question is, and just let me hear. Null. Okay. You have this list. Let me say cons. What happened? What happened if, for example, I say cons to process, and I say that this one, it will be like a list dot next. What is saved here? What I have here?
8.
Probably 8 and next.
8 and next, right? 8 and next. Null or object. Okay. Sorry. Sometimes I forgot to do it. Okay, 8 and next. This one, if you see it, this is repetitive. Next. But let me ask you something. Let's say that I have this one, and then I say process dot next. What I have here?
Same thing.
Why? Why I have the same thing?
I don't know this word in English. Kaiko.
What is the word in Russian or another language?
Обращаться. Вы обращаетесь все равно к следующему после вызова.
Okay. You get connected. Someone can translate me that word? Abrashai. I know it. I just don't know the translation. You get connected, but it's like a someone get connected.
Yeah,
The idea,
you are calling anyway, you are calling the same thing by name.
they say exactly. You are calling the same. Now, can I ask you something? What is going to happen? What is going to happen if I say, in this case, to process dot next equals value 15 next null. What is going to happen with my list?
Instead of last next null, you will put another object. 1 next, 2 next, 3 next.
A next, and then the next we have an object. That is completely correct. For someone is not clear what I am doing right now, why I am modifying this process, but the list here is getting modified. For someone is not clear that, or for someone doesn't make sense that.
Yeah, I'm trying to understand why. So you assign to the, so instead of null, now we have this object, right? You assign to next.
Because this process that you are having here, this process is a reference to here, to this element. Then to this element next. Then here I am saying next, then next. And I say this one is equal to this one. But what is happening is this one is a reference, right? Do you remember that here we were talking that This one is just a reference,
Mhm.
the memory. Then I am modifying the original. I am creating an entry point. This my process is an entry point, to this. Because what is going to happen? Is going to happen? Let's say it. Let me just if for example, what is going to happen if I say cons my let's say it cons head equals to list, cons equal to list. This is a reference, and now I say head dot next equal null. What is going to happen right now with console log list?
It's gonna
Yeah, you will not have other objects, only first.
be just 4 and now.
Value for and next null.
Exactly. Mhm. Okay, now we are using as a reference. You will right now with this knowledge that we have it, that first one, I can modify one element. Using a reference. I can move or I can transverse the object based on this. Let's go in this moment, and I will just show you something. Someone has an idea. How can I show the last value of this list without using dot notation? And I will tell you something. We need to use something similar of the last class. What do you remember? What was the topic of the last class? Who remember?
Mm,
Recursion, right?
Recursion. And I will tell you something. Maybe you will use something like a while. How you will show me this number 8 without saying list, next value. And you know what? I really want to have this at least one extra element value. I am the last value. Value. In here, I will go with next, and I will say null.
In this case, every node's value can be different type, right?
Whatever you want. What is saving over there is not important. It's just remember that this is, I can even have another object here. I can have another object here. Doesn't matter.
Okay, sorry.
And that will make it very interesting. This is the base.
we
I
need,
would like, yes,
oh, last, we need 8 or last value?
the last value. I want this last value, but you don't have to use dot.
You said while, right? Like while our value will not be I'm the last value.
No. Can be wherever.
Okay.
Later, this has to work even if later I do again like a value.
I mean, I just read it, the string while list
Or
dot value equal I'm the last value in as a string. It will be like condition, like if jump to the value deeper and deeper. I don't know.
I would like you to think, because this is the idea of the linked list. First one is to use recursion. And that is why if you see it all the time we have the word next, 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 next. And I have to be showing you the reference thing. You need to use a reference. The reference, you are moving it in one position, till mm,
till the next will be equal to null.
then you have the last value. I
And
would
then
like you to,
get the value.
then you will get the value of the element that you have to do that. It sounds easy, but I would like you just to see this one is already one dynamic data structure that we can use it. First, I want you to see it, and then we will implement it with code creating this data structure. Okay? But I would like you to try to right now with this list, give me this last value.
So do we need to create a recursion function?
Not needed right now, but if you want it, cool, do it. But if not, I will be fine if you just create one while here. Be fine.
While
Be Yeah, and at the very end, you will just say console.log. Maybe here we'll call it whatever, and just show the last value. Here, somehow you will say like a dot value, and there will be over there. Remember that you need a reference. Create a reference. Usually this reference will be like something like a let, because you will have to reassign it every time that this reference is moving. This while. Okay. Till the reference next is not null, right? It's not null. Then you have it here, move the reference to refer to the next element. And then you say like this one is the reference value that you are getting here. I just want you to try to do it. If not, I will do it myself. But everything is what we have been talking during this hour.
Can you scroll up a little bit just to see what was name of, like, to see all object? Can you scroll up a little bit?
Yeah. I will give it to you. I'm sorry. I mean, you don't have to be writing this. I'm sorry. Thank you for telling me. Yeah, there you have. I mean, it's not needed for you to be coding an object. Mhm. Let me just add here 5 minutes. Yeah. Oh, thank you, Victor. Yeah. Okay. I think like someone is close to do it. Someone raise your hand if you are trying. You are not trying. Oh, thank you, Kai. Oh, exactly. Okay, the idea is like this. Right now, I like it how uh, thank you, Joanna. Yeah, okay. It's very interesting. Okay. Kai, why you call it current? Oh, I will call it like this. It's very nice. Yes, Kai? It's very
The
interesting.
current, set the current
Okay, yeah, current value. Yeah.
level, or what is that?
Yeah, the current level. And we have this element because this is a repetitive operation. We can say current value done. In this case, current value dot next is different than null. If it's different than null, the only thing will say, hey, we move the reference, right? Current value will be equal to current dot next. And what is this? This is called move the reference. Move the reference. Okay. And then when you finish, you say console the log current value dot value. Current value, right? I am missing.
Now check your 77 line. Well, Mario, 77. There 77, there extra U. Wow.
Okay. Okay.
In
Thank
six- in 69 too.
Also, it's extra A after L. 69.
69. No, 69.
And on 65 too.
Okay. Okay. Then here I have to say value. Okay, this one is okay. That was correct, right?
Yes.
Okay. Then I give you some error over there. Okay. Okay. Then here you have it the 15. Thank you so much for being patient and sorry for the mistake that is happening when you are writing and writing. But that is you want to get the last element that you have it. Okay. With this one, you are seeing that with a reference, I can just go and add to the end or add to the beginning. Okay, cool. Thank you so much for it. How we add to the beginning, that will be the next one. How to add an element to the beginning. And you always just, here you will have a couple of the steps. First one, you create all the time you create cons. Let's say it, let new reference. And this reference that you have here, it will be just to, for example, to the list, and you have the reference, right? And you say const new list, let's say const new list, and then the new list will just have it, for example, value 15, and you say next, it will be the new reference. Next will be the new reference that you have it. It's a new reference that you have here. One thing that I did here, it was I have to create a widget. If not, I will not be able to review it. Then I will have list. List will be equals to, in this case, new list. What happened if I just console log this new list?
And,
New.
can I have same address as list? New list.
Let's see.
Yeah.
New list will have new and old values. Oh, what is this?
Well, this is the 15 that I just added. Then I have here the 4, the 5, and everything over there.
It's a tricky question.
Yes, it is.
Can you go up? So what was the old value for this? It starts from 4, right? Or no?
It starts
Oh.
from 4.
4, 5. Where is 8? Is it somewhere there?
In this case, we can just print it like this. What do you think if we print it again here? Look, I will not just do it like this. I will say current value 2, current value 2, current value 2, current value 2, current value 2. And let me just say it console.log current value 2 dot value.
Oh, it
Just to
means
see it.
it's not showing everything. It's just referring as object here in the first place, in the first console log.
And the first console log.
Why it's returning next as object and stop there?
Oh, I'm sorry, which line?
No, you did console log before. It's a first console log. It's 15 and value 15.
This value 15, because I added here the new list. Look, list is equal to new list, and the new
Yeah.
list, it has the value 15,
Yeah,
and the next,
It
the
said
reference.
it is printing out the same, but why it's kind of stopped? It didn't show
This
the
one.
value, and it says just object.
Here.
Yeah.
No, because it's stopping. It cannot show the full information.
It can only show few.
Yeah, we can show just a few. Yeah, because it's too nested, then it's stop it. But it's just how Replit works. It's
Okay.
nothing else.
In case we not to, we need to see all the values, and we need to look through. And
You need to look through, and this is not common that you have to look the elements. Like I think like a 3 or 4 nested element that will show you. They will not show you more. Where they are next. Yeah, it's just saying that. For example, let me just show you something here, just for curiosity. Console.log, and we have it here. This list, right? Let's just say a list, and let's go 1, 2, 3 more. Dot next. Okay. Here you have it. Right? Then you have after 5 you have 15. After 5 you have 8. Here it is. After 5 that is finished. Here is the value 5. Then is 8 that you have here. Then you have I am the last value. And then you have 15. It's just truncated the visibility, but nothing more.
Okay, got it.
Okay, cool. We will stop here. My idea with this exercise, or what we are doing here, is to remember how the object works. And the second one, how a reference to an element allows you to create an entry point to the data structure and continue moving. Now, what do you think is the big of notation? What do you think is the big of notation of adding a new element to this list at the beginning?
ON if I will compare with the arrays, because he also no. Okay.
The reference is still in the same place. I didn't change any reference.
What do you mean? You changed it like the parent. You changed it main parent.
No, they are still in the same space of memory.
And
Just
same
change
level,
the
same
address,
level.
right? Just head, the head link showed as the beginning of this list, and then the existing list put it in the next. So
Exactly.
they-
What I
something like that. It's like snake, right? Like a
that
snake.
is what I wanted to
And-
show you.
Okay.
Think this is the linked list, and the only thing that I did is I connected one new node into the beginning. That is the only thing that you are doing all the time with the linked list. This is your linked list, and what I did is, oh, you know what? I don't want this to start from here. It will start you have the linked list, and this is the tail, right? And this is the head of your linked list. And I added something at the beginning of the linked list. And now your linked list is bigger. Later, I want to add something more to the linked list. This is the head. I just connect something to the head. And the linked list continue being the same. And you are just extending the beginning of your linked list. It's exactly as Kai said, it's just a snake of different elements that you are adding one after another one. And that is why it's so cool, because removing in this case from the or adding to the beginning is because of, in this case, of one, because we are using a reference to do that.
But in this case, Mario, we are creating the new
Node.
variable, and it's kind of a lot of
Space.
movements. Yeah, about
Yes.
this. Yeah, we are
Yes.
just creating.
That is why we don't use it in this way that I am showing you. Right now, I am showing you for you to see every single element that is over there. But what do we do, or what we are going to do right now? We will create in this case, a class that is doing everything for us. That it will have the method look, go to the end, go to the beginning, have the head, and all those methods that will exist into one class. And we will not have to be implementing this one. First thing, the linked list, they are already implemented. They already exist in this case, right? They have their own structure. The only thing that I wanted to show you is how they are working. And I will show you, we will create the node. This is called a node. The node. We will create the linked list. We will create the constructor. We will create, in this case, for example, the size of the linked list. We will append. We will also remove. Like we will also have find. We will also have print. And we can also have get size. All those are the different methods that we have it, and we will have to try to add it. But the one thing that I want you to understand, everything will have the same structure. That is this one. This is the key of the linked list. Create a reference and move into that reference. Imagine that you want to add to the position 3. What you will do, for example, if you want to add into the position 3 here, you will iterate 3 times, right? Iterate 1, 2, 3. But you will continue this. If will be search, you can say when value is equals to some information, they will be the same. Then all the operations related with the linked list, they are inside a while. The big value about linked lists is, first one, inserting at the beginning is big O of 0. Then we can also create it in the last position. We can do it adding to big O of 1, 2. Another thing is we know which elements go after the next one, and they are just more efficient when we are talking about processing. And we will implement the linked list right now after 10-minute break, if you don't mind. Questions so far?
So can we use for loop for linked? No.
Yes, but this is the idea, Kai. You never know how many elements you will have into the linked list. And the idea is to use the iteration to go inside to other one. But as I said last time, you can use a for loop. What you need to know is the size of your linked list. If you know the size of your linked list, you can just be moving. What the inconvenience that I see about a linked list using a for loop, this is me. This one gets a little bit complicated because after you are moving all the elements and you are changing the current value, then all the time you will be using the main linked list to know the size. It's fine, but I think that the most common way is using a while.
While, okay, okay, got it, yeah.
Mhm.
Yeah.
Okay, then let's go and take how many 30 minutes break? Not 10, right? Okay. 10 minutes, guy.
Send
Yep.
some of it, part of code.
Yeah. I can send you everything here.
Ah.
I can send you everything here. And at the very end, I will go to a link. Okay. Then see you in 10 minutes, guys. Okay. Let's implement it. First of all, I will be clear. The majority of the time, the implementation, it will be absolutely the same. It doesn't really matter which language you are using it. The usage of linked lists, we can enumerate, for example, a couple of them. Let's say it. I have here a list of different things. We need it, for example, when we need a data allocation that is dynamically, we don't know how much we have it. Inconvenient is a space efficiency because of the arrays. The array sometimes you can create one in a specific spaces. In this case, like a rate of 9, and you are not using the nice spaces, you still have it. One thing that I want to be very clear is the linked list is the basic of implementing something more complex, like a graph, has tables, or in this case of trees. The idea is based on linked lists that we are having. Then my plan is we see linked lists, and then we go to more complex data structures into the future that we have. And they are very optimistic. We have the majority of time, they will just appear in this in the same way. We need two different classes. One class. Let me just go here. Okay. Here we will have two classes. One class, and this we will call node. Okay. This node will have a constructor. The constructor, what you will get? The data. And guess what? This constructor will return you two things. One is this dot value or data, as you wanted to call it, right? Data equals data. And we will have another one, which is this dot next. And we initialize it with node. And that is our node. What I am constructing here, is just this one. It's the basic. If you see it, the linked list is just a construction of more elements like that, right? It's just a value next, value next, value next. Oh, let's use the name value, okay? Value, in order to have it here, value. And we have it, value. There we have it. This is the node, and we just call it like that. Then we have the class linked list. The linked list. Which are the main elements that we have? Okay, first we have a constructor. This constructor, you have some information. At the beginning, the constructor, we have this dot head, right? We have the head, and the head start with null. We have it independent, but we need some dots. Why? It's just nice to know that this element has a side, right? This is the basic linked list that we have it. Have a linked list, and this is without nothing convenient, right? We don't have anything. Right now, what we have to do is we will create the first method. The first method is to add an element at the beginning of the linked list. Linked list. The first one I will do it, then you will. There are some people that they call it append. Okay, append or add, increase, insert. They are just synonymous that we have it, right? There are a couple of things that we have to do it. First, let's call it like add. Let's call it add. And you will have a value. This is in a class. What is the name of this? What is the name of this function? How we call it in a class? How we call a function or action in a class? How we call this one? It has a specific name, right? Someone remember?
A method?
A method, exactly. Here they're calling methods. Okay. Just to name it in the proper way. If you remember, what we have to do? First, we have to create a new node. Okay. And then let's use the idea of value. Okay, the current value. And then we will just have another. The current value will be, yeah. Okay, the value. Let's create a node. On the majority of the time you will have node, and we say new node. Okay, new node. Here we have it, new node, and we have to pass a value, right? The value will be this value that we are arriving from here. We will have the value that we have here. Okay. If we are going to add, there are in this case two things, or two cases. One, the linked list is, and the second one is the linked list is. The linked list is empty. Okay, because at the beginning, the head doesn't have anything, right? Then we check that. If we just have this one, we say if, remember that we have access, this dot head equal null. Okay, what happened if the head is equal null? Then we just say this dot head will be equals to not. No more. In the contrary, if there is something, we use the same idea that we have there. We say let current will be equal to this dot head. Okay, the current will be just head. And we just move till the end. While current dot next equal or different than null. Oh, I have one extra, right? Thank you for telling me. Then I have one extra here, and we are just moving. Current will be equals to current dot next. Okay, that is what we have. Okay, and when we finish, we just say current dot next will be equals to not. This one is the same that we were doing before. I am just adding it till the end. In the other one, I was adding to the beginning. This is adding it at to end, and you can add to the beginning, right? Add to beginning, or whatever, however we call it. If there is nothing in the head is equal to node. In the contrary, if there is something, how many elements do we have in the list? I don't know. Then, in this case, I create a reference. I move the reference, 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 till end. Move reference till end. Add element to the reference. And because it's a reference, actually, this current docnext is also my linked list. Then because it's also my linked list, I am modifying the data that I want. And that is so cool. We have, look, we already created our linked list that is adding till the end. We wanted to use it. Okay. Remember something. We have this size. Maybe after adding here, we just say, for example, this dot size, this dot size plus, right? Just to say the size. Someone remember how we create our linked list? Linked list. How we call the constructor in our linked list? How we initialize this linked list here? How can I use the class?
So new.
New, right? New, yeah. New linked list. Linked list. Okay. Console.log linked list. What is going to print me here?
Empty. Or
Oh, Mario, I just really confused with a lot of references. What was the first class?
Yeah.
So-
Node.
Yeah, and value. Value is just what is value? It's just what, nothing? Like Yeah.
Right now I am not using it. Look. Okay.
why?
Let me
Okay.
remove this one right now. Right now I am just using this one, the vector.
Okay.
I create a linked list, and the linked list called the constructor, and the constructor create me the null and the size.
Mhm.
Here we have it. That is my linked list. And if I say type of linked list, it's an object.
You didn't use the first class? I thought you put it.
Not yet. Not
Oh.
yet. The second one, I use it here.
Yeah, because
Yeah.
it also had a value. I thought you took from the first value and
Oh,
used.
no.
Okay.
It is just normal because remember, just to continue with this, if I say linked list, I can call a method, and that is my method. Add to the end. Add to the end, I can add whatever I want. Let's say I will add just to have a name. Okay, I will add vector. I will add here vector. Vector. And now we say console.log linked list. Now, what do you think is going to print me here? What it will be like this? What do you think is going to print me? How will be the shape of this element?
I don't know, vector is key or value.
I think
No.
instead of
No.
head. Okay, I think a head will have object. I think,
Uh-huh.
and inside the object will be vector as a value.
Uh-huh.
And next null.
Uh-huh. Let's see it.
I think, yeah. It's gonna be.
There it is. In the head, node is a value, and then is next, that is null. But here, I think I am having an inconvenience because I didn't increase increase the value. I will increase it here.
Size, okay, yeah.
Yeah. Mhm. And the size is 1.
You used add to end and you place it vector into the head, not size.
Mhm.
I thought add to end he will put inside of last property. Last key.
Here. Let me add a new one here. Let me add, and let's add here, for example, let's add Nur Sultan, that if I write it over there and we save it, what do you think it will be the shape of this?
I don't really know where will you put these names. I add to end. He's putting like at the end of object or where?
You are using, where you are saving the information. All the information is getting saved into the head. That is your linked list that you have here.
Head is just random name, right? Or it's not random. It's some keyword. Is it some keyword?
No. Okay, let me just go back here. No, it's okay. I really want this because if not, I cannot go with something more complex. If we don't go here. Okay. First, let's just start here. This is just a simple class, right? Till this moment, I want this linked list is calling the constructor. The constructor create an object, and that object has 2 properties. One property is the head, this one, and one other property is the size. That's it. Inside the head, that is how you usually call it in the linked list. Inside the head, you are going to save your information, all your reference. Okay. Then the second one that we created was, and you can call it, we create a method to add information to the head at the beginning. Okay. We will just create a method. This method will allow me to add information to the head. That is the only thing that it will be doing. Because for now, if we just saw it here, console log linked list, it will just go here. We'll go to linked list. This is what you are doing. Linked list, call the constructor. The constructor create an object, and that object has head and size. Head and size. No more. Till that moment, we are okay?
Yeah.
Okay, cool. Now, the linked list, the idea of the linked list is that inside the head, we have an object, and that object has a node. That, for example, if I call node, is creating me one object. Okay, now, the name or the method doesn't matter. We can call it whatever you want. For example, we can add the beginning. Okay. And what would you will add? One value. Doesn't matter. Like this is just a value. Can be a number and a string, wherever you want to pass it. Okay, wherever you want to pass it. That is not important. What you are having over there or what you are adding. It's just an information. Okay. Now, because a linked list, the idea is in the head we save nodes. We save nodes. That is why we created this class. Then we create that node. Then we create, and we can call it let or okay, let or console, whatever. And we say new value node. I just wanted to be descriptive. And we say new node. Okay, and here we pass, what I pass? The value. What I pass the value. Let me just console.log this new value. Let me just console. This method exists inside linked list. That means like this linked list, when I call the constructor, create the object and added all this method, right? And added all this method. That means that this method add to the beginning exists. Because it's a method, I can add a value. What type of value? Any, wherever I want. This is the value. Following this logic, this method will call here, will arrive, it will create a node, and it will console log the node. What will console log here? What type of data will console log there? That is the main, my main question. What is going, someone can tell me, what is it going to console log over there? What type? It will be an array, it will be an object, it will be just a string, it will be, I don't know, what I am passing here. What is going to show me here? Yes, Arina? I saw you over there.
Yeah,
Just go.
a second.
Maybe just object with one property, which is value just.
Why just one property?
Because no, it's both properties.
Which
Yeah.
is the second property?
Next null.
Next null.
Yes.
Because this one is calling this constructor. And this is just the idea, this calling this constructor. Then this value is the value that you are passing here. This, let's just go here. This method, this one here, is a reference to this one. This value that is going here is getting inside. Then when we are calling new node, what is happening is calling the constructor. And the constructor is giving you back these elements. And this element gets saved here. And this one is what I console log here. I mean, that is how the information is passing, right? This is a reference to, yes?
So in the line 24, you're sending some string, right?
Yeah.
Does the string affect somehow to the node? I mean,
Is the value of the node.
yeah, the node had two properties, right?
Yes, you have two
The new
properties.
string,
Okay.
what you added the new string to,
Yeah.
and what he has right now after this string, you put it one more property or what?
Right now it is not, right now, no, because right now I am just creating the node. If you see it, the linked list is not affected. The linked list is not affected. Right now, what is happening is just I just create a node here. I just create a node. If we see it, if we see here, look, it will just say, look, this is what create. This is the node. This one that you see here is this line. It's this one. This element is the new node that has a value and a next. Now we have two options or two elements. The linked list is empty or it has a value. If this dot head, right, is this dot head is equal to null, that means, because that is how it's starting, right? That is how it's starting. This is null. If it's null, means there is nothing inside. Then I can just basically say, okay, this dot head will be equals to new value node. And at the very end, I will just say this dot size plus plus. Why? Because now I have one element into the linked list, right? I have one element. Now let's read what is happening here. I am adding to the beginning. I am adding one value. This value is creating me this object. This object has value and next. If the head doesn't have anything, now the head will be this node that I am creating, this one right here. Now I can just go and see this, and I will say, this is my linked list after I added one value. And here it is, look, the head was null, then the head is equal to the new value, and the new value is this one. Then you have it. The head has a node, that node has a value with this information, that is the one that I passed here, and has a other property that is null, that is just the end of my linked list.
It's cool. Yeah, I see what happens.
I am 50% secure what you are saying, but let's go over it. Someone else questions so far? Someone that is very lost. Okay, just right now. This is the beginning for more complex data structure. I mean, like, I cannot pass to something more complex. The idea here is the reference, the only thing that we have. Now we have the other option. The other option is if there is something in my linked list. Okay, if there is something in my linked list, okay, I have something. Then I will create a reference. Let reference all as you want. And what will be the reference? This one will be equal to this dot the head, because at the beginning, right? Okay, I have something. Okay, get the head. Get the head. Okay. And now I start asking. I can start moving into say, hey, while reference dot next is different than null, move. I just said reference will be equals to reference dot next. Okay. I am just moving. And what happened when the reference ended finding next? The only thing that I need to do in this case is reference dot next will be equals to what we created, the new node. That's it. I enjoy this one is absolutely the same that we were creating before. Do you remember when you were going element by element? We are doing the same. If the head has something, move to the next one till there are not elements into my next property. When I clash or when I touch, when I hit null, that means, okay, there is nothing more value. That is the tail. That is the end of that property. Okay, because that is the end, I can just add it. Let's say it right now. I will add another element, but here I will just say like, hello, Mario. And I can just console log my linked list. Someone can tell me, how do you think the shape of that element right now? This, we used to have this one. Look, we used to have this one. We used to have this one. How is looking now? Don't pay attention to this one. How the head is looking after I added this hello Mario.
So your head is not empty right now.
Uh-huh.
So you will use else, which is
Uh-huh.
reference. And his next is now, right now.
Uh-huh. Uh-huh.
Wait a second, okay, just sorry. If while it's not now, okay, it's now. So I think he will just create inside of next instead of now. He will create another object which will contain our hello Mario.
In the value, right? In the value will say hello Mario. And
Size or not?
it will say next. Because remember that this one, new value,
Oh, mhm.
has value, it has next. What it will have here?
Now.
Null. Exactly. It will just go ahead and we run it. And you have it, look. Node. Oh, okay. Oh, I am. I don't want to be showing this because it'll make you a little confused too much information. Here we have it. Look. Head, value. This is the value. Next. Hello, Mario. Null. And if we add a new one, by the way, if already you notice, the name is not good because I am adding to the end, not to the beginning. To the end, I can just say, this is the class. Oh, I just remember something. This is the way. I hope someone knows this reference. And here you have it. Next, we have a node. And what is that node? That element that exists over there. And this is the way. We are just adding at the end. Actually, this one has to be called at the end. Not at the beginning. It's a mistake call it at the beginning. Because we are adding after the last element, right? That is what we are adding at the very end of that element. We create the linked list. We added one element. Then we added a second element. Then we added a third element. And look, here I have the size of my linked list that I can basically say console.log, linked list dot, and here you have all the method, and you have size. Basically, you can just go and see, decide why. Sometimes this is just useful to have it this way. I would love right now, I would love that you implement add to the beginning of the linked list. You can call it, in this case, add to the beginning. And here you will have a value and you will implement it. It's almost the same. Just right now, I am adding to the end and I want you to add at the beginning. Every time that I add a new value, it will appear at the beginning of our string. Here is the copy of everything that we have it over there. You will also check this one. You will create a new node. You will check, in this case, this is the beginning. And this one will be very similar, but you don't have to go to the end. You can basically just join it at the beginning. It's just to see how the references are working. And I would like you to add it at the beginning of our linked list. That makes sense?
Yep.
Okay, Nursultan, yeah. So what else?
Yeah, I said yes.
Okay, thank you, guys. I did it. Okay, please try to add it. You have the copy. Uh-huh. Okay. Okay, I will. We see like 3 minutes more, isn't it? For you, this is quite clear, right, Nur Sultan? I don't have to be worrying much about it.
Linked list, you mean?
Yep.
Yeah,
Okay.
I've struggled in the past, not now.
Yeah, it took me time to understand, mostly because of all the bunch of the reference. But the idea is like if we
Yeah.
got it, yes.
No, I didn't have any questions.
Oh, okay. No, the idea is like if everything goes well and after linked list, we can start looking for trees, and then it will get fun.
And trees, yeah, they're fun. They're really fun.
But honestly, it's very simple. The difficult part is to finish understanding that to make sense that they are just reference, that you are just moving into the object that has the same shape. Because basically here you are just using the value and the next. Is here, then go next. Is here, go next. Is here, go next. It's just
It's
like that.
much better when you like draw it. It's like visually represents it more clear.
Well, just as I found it a little bit weird because honestly, a linked list is basically. Oh, wait. Let me see.
Yeah,
The
this is
majority
the
of people, yeah, no. But let's say like we wanted to, I wanted to do it like this is the value.
address memory.
Don't take me that much, but usually you have the value and the next. The next goes here, and then we have it here, the next element, and the next element is pointing to the next element. That is how for me was easier. There are some people that they represented like this: value, next, value, next. At the beginning, I tried to explain that using objects and see it like a big object or element. But okay, well, someone wants a little bit more time, or we do it here. Okay, add it to the beginning. As always, the linked lists are just basically a reference. Most of the time, you will just create it. Just say good. We say new value node, and we create the new node, right? That we have it. The new value, we just pass the value that we are bringing from here. There are two options. The first option is that for example, that this dot head will be equal to null. This is the easy case, right? Okay, because it's already null, and we just say this dot head will be equals to new value node. That is what we have it. And the other case, well, in the other case, we have something into our head. Then let's create something that is current. This current is dot head. Okay. We already have that element into the head, right? If we have it into the head, what we need to do? This current is a reference to the object that we have there. Ah, okay. This is absolutely fine. Or in this case, someone try to do it. What we can do later? We already have a reference to the head. Then, do you remember that we did it before?
You created new object, what contained it, like what you wanna paste before head, I mean. And
Then,
like in this case, it's new value node. I think
new value node. Okay, new value node.
it's it's a oh I don't know, Mario. I did it by different way. Let's do like you, because I tried. I couldn't do that.
Okay. Nur Sultan, add to the beginning.
Add to the beginning.
Mhm.
Beginning. We need to re-reference the head.
Okay, let's say let reference head. Okay, let current. Let's call it current just to keep it like that. This dot head.
And then this that hand equals new node, new value node.
This dot head equals to new value node.
And then this that head next equals current. Oh no. No. What we're trying to do?
Copy it. This dot head
What we're trying to do?
is added to the beginning of the head.
Oh, stop. Give me a sec. New value node and then. Oh yeah, current. Yeah.
And then current. Exactly. And at the very end, the only thing that we have to do is always increment in 1. I just will close this guy here. This is here, right. And then just add. Let's add it to the beginning and say linked list dot that we have added that to the beginning. I am the new first value. And we just console log the linked list. For me, this makes sense. I am the first value here. I am the new first value. What Nur Sultan did it right now? Yes. Tell me, Nur Sultan, I think you want to say something. Okay,
No. Just
Okay.
forgot to turn it.
Forgot what?
To turn off the microphone.
Okay. Okay, what is happening here is we are created a reference. Okay. We are creating a reference here to the head. Now, the head is equals. Let me just try to make it more visual if it's possible. Right now, in the head, I have one object with some information that is on the linked list. Okay, listen. And it's all of this object, right? It's all of the object that we have. Now we say in the head, that is here, add the new node is the one that we created. And then we say this dot head, that is the linked list head next add what it was in the head before. is basically the only thing that we are doing. You create a reference, you replace the head with the new node that you created, and in this moment, you added the new one. Let me just go here to AutoDraw. Maybe here will make, I hope it will make more sense. You have your linked list with one value. Then we have here with another value. They are added. Right now, this is my head. This is my head. I want to add to the beginning. The first thing that we do here, it was create a new node. Okay, we create a new node. And what I do right now is I create this current is here. Is a reference to this head. This is a reference to this head. Here. Now what I do, I move the head to the new node. What is here moving stuff? Here. Now I take the head and I move it to the new node. Okay. And now what I do? Head dot next, go to current. Okay, what is next? Next is this line here that you are seeing here. Then this next is moving to current. And current is a reference to this one. And then you are making your new linked list with the element to the beginning, because basically this is current. This is current. And that is what you are doing it in this operation. Create a new node. You make a reference that is going to the head or to the old head. Then you move to the head to the new element, and the new element has two values that have the value in next. And to next into this line, you put current. The current is a reference to the previous head. Make sense?
Yeah, almost.
Almost. Okay. That made me almost happy.
But yes, I mean, what you said, I understood. I just need to think about it, and yeah, but it's for now it's clear.
Okay, I'm happy for that. Now the next operation that we have to create is remove. Let's remove from the beginning. Let's remove this one. Remove from the, let's call it remove from the head. Remove from the head is similar. We need to check if exists. If the head has something. If doesn't have, we cannot remove, right? If the head is 0, then you cannot do anything. If the head has something, if the head has something, remove the first value. The first one is not that complicated. Let's see the operation. Okay. This is our head. What I want right now is to eliminate from the beginning is head.next instead of being head dot next, the only thing that I have to do is move the head to the next element. And this one has to be eliminated, right? Then I want to move, I move the head to the next. I move the head to the next. I move the head to the next. I want to go to the other one. I want to move to the next. If there is nothing, okay. If there is nothing, we just have to say that is 0. Let's start with the beginning. Let's say if this dot, and what do we have it? Size is equal to 0. Okay. We cannot do anything, right? If the size is 0, then I cannot remove anything. Then let's call it, if it's different than 0, I can do something. And what I do, I create a reference. I say let reference or let current equal this dot head. What I need to do? I need to move current dot current will be equals to what? Or current will be,
What?
sorry, back.
So you are just gonna choose current next and put it as a first. I mean, yeah. You need
And just add it as a
the head, just this head.
this get equal to current. And we have to do something here, right? We have to say like this dot size minus. This is almost correct. Exists one moment that is not correct. If the size is just 1, right? The size is just 1. Okay, let's go over here and we eliminate. Right now we are eliminated from the beginning. I am the first value and I just say here. And instead of removing from here, I will say remove it from the head. Let's go and see what's going on over here. Look, I am the first value. Now I am the value. Okay. I can remove again from the head. Okay. Hello, Mario. I am removing again from the head. This is the way I can continue removing, and I will be always removing from the head. And here we have it. If arrived at complete null. We are just basically just removing from one element to the next one. We are just moving the head to the next element. That is the only thing that we are doing. Just moving the head. We have another operation I would like, that is remove from end. That it will be quite similar. If it's not 0, we'll do something. If it's 0, I mean like if we are calling this function when doesn't have anything, in this case. No, it's just giving us the same information. I cannot remove from another one that when it's already 0. Then we have to remove it from the end. What is the idea to remove to the end? Okay. The idea to remove to the end, we will have this as reference. What I do is I create a reference and I have to go and check here. I want to remove this one. That means like from this element, next, and the next is null. Okay. And then I can remove that element. When the next is null. If the next is null, I can do it.
Is it with while, right? Again.
It will be with one while that we will create in this case.
So
This
I,
will,
until our, what was the key of null? Next, right? Until our next will be null.
Mhm. Or in this case, you can even create it with a for loop because you have the size. There are different ways that you can do it, but the with while is the best option. Mhm. I would like you to try to do it. But remember here, the most important part will be basically to go to the to get the when the I will give you some hint. Look, you will have to check while let's say that current next exists. It doesn't exist, we just keep it in this case. That is the most important that we have. When current next exists. If the current next doesn't exist, well, then we have an inconvenience. But it's very similar. If the current next exists, move. The current next exists,
Do we need
move.
to do it in our replit or video? Just here.
Oh, do it wherever you want. You can clone it, mine, or you can do it home. That is okay. That is, I would like you to add remove from the because remove from the end will be one of the I would like you to try right now. We have to check a couple of things. Let me just. The first one is, for example, you have to check if there is not head, right? You can check if there is not head, something, right? There is not head. Or for example, if there is not a head dot next, okay, then in that case it is something different. Okay. It's not, there is not head. And here, you have to check what to do. For example, if it's there not head, I will just return there is nothing. If there is next, that means that there is just one element. We can say this dot head will be equals to, and we can just basically initialize it. And what do we have it over there? If it doesn't have head, how we just look and we just say this dot head equals null. In the case, in the other case, if there are more, and we always return, right? We'll return. If now we know that exists something, then we have to, you create, for example, in this case, the previous element and the current element. You have to track the previous element. There are two ways. You can check, for example, next, that could be one option. Or you can use to reference. It's easier when we are working with Java, with React, right? Like select, add it, give it, and everything. This is also part of the thing that we had to check it. Mhm. Here is all the code. If you want it. I will give you a couple of minutes. And we just, then there will be this dot size equals 0, right? We do it together. reference equal this dot head, right? While reference dot next exists, I just say reference equal to reference dot next. And then what we do it? You can just say it reference dot next equals null. Right? Oh, I have one answer here.
I'm not sure. It's very similar, but can you check, please? I'm not sure.
Yeah. Yeah.
I also did now the next.
Yeah. That is null is cool. Okay.
It's different.
It's a little bit different because I am using this next. The idea of the next, and I will allow you to. Okay. The idea of the next is like this. You have the head, and we make a reference, right? Make a reference. The reference is here, and we want to check the last one, and we go reference next exists. Then we move the reference. We move this reference. We move the reference here. Then we check again. Next. Okay. Next. Exists. Okay. Then we move the reference one more time to the next one. To the next one. And we just say reference next exists. Okay. We move again. Reference next exists, and next doesn't exist. Then reference next will be equal to null, and we eliminate the last one. That is why we use next. The idea is like the next will be null. We want to remove the last one, and that is one solution that we can do it. That is why when we are removing from the last one, we usually are checking from the next element. By default, I already know that the head next, I already checked it, right? And I know that next exists, at least one that we are having here. And we just say this dot size minus. I saw it.
Yeah, with next is cool. I was thinking how to get the next one, but I never thought about this. So Mario, can you go back to your drawing?
Yeah.
So here, we are not removing the last element, right? So because we are removing the previous, what is that?
The previous
Reference.
next. Yes.
No, we are removing only the from the reference next value.
Yeah, is
Not
this one.
Where
Not the
No. We are only removing the reference to the last element. Is that correct?
exact. It's completely correct. We reference the next element, and that one.
It's
Let's
just
say like
you are just so you are just removing the chain, not not the value.
Exactly. I am just removing the chain. I am just
Yeah.
taking the node and putting it outside, and then the garbage collector will deal with it, not me.
Okay. Yeah.
Interesting.
Ah, yes, Victor?
Oh, sorry, my bad. I forgot to turn off. my-
Okay.
Oh yeah, my brain is refusing to.
So Mario, it's really hard. We need to practice. Where can we practice with other tasks?
The first one is here, my dear friend. Here you have it.
Oh.
The last three exercises here are related with this, and I will continue. But for this time, I want to keep it like this, and I want you to try to do remove element in X position, and I want remove after X number. Also try to do like this. Find an element in the list. Then replace element in the list. Try to go with this. You can do all the operation here, all the operation. If you don't feel comfortable with linked list for the next class, we can even repeat completely. But after linked list, I will pass to tries. The tries are the same idea of the linked list, but the linked list, for example here, the linked list are just one element. The tries are two elements, two reference, left and right. And then we are start to creating like this.
There can be more.
Yeah, but I will just be
Okay.
right now with, and the majority I will just show in balance. And there are binary trees, everything that I will be working. Hey, don't expect that much.
Okay.
Yeah. For the next class, if everything goes well, we will start binary tree. And if we are saying if everything goes well, maybe we will, but we can just go with entries. And if you see it here, then we have this one. And what is this, Nur Sultan?
That's graph.
Yeah, exactly. Then if you see it, this is the base. Then we go with binary trees. Then we go with entries. Then you can go in this case with graph and after graph, I will already, we can have something that are called tries. But that is basically everything that you needed with this is practice and go. I want to be very clear. This is not something that you will be using when you are working, not even front end or back end or anything. But it's good to train your mind and to see how everything in this case, how the information is flowing. Yeah. For today, I will stop it like here. I would love if you try to practice more. Please watch one video. I am sure that there are people that will explain you even better the linked list, but I try to share with you everything how I understand it or the way that I work with linked lists.
Mario, can you please show that I didn't catch the tasks? You said remove element in X position. We need to like give this X.
Yeah, for example, remove in the
I see.
third node. Yeah, the third node, and you will go maybe a for loop, right? Like a 1, 2, 3, and you will remove that element. But the most important removing is the referencer that you want to do it. For example, let's call it linked list, and it will be like a remove it from X position. And you say the position 2. then what I will be expecting, what we're expecting, for example, is that you will remove, for example, here you have it, and you will remove this second value. This one will be removed. And if there are 3 more values, then the value that is after, you have to bring it before. The idea will be like this. Let's say like I want to remove this element. Then I will go here. Is this the element that I want? No. Is this the element that I want? No. Is this the element that I want? Then this next will be to the next element. And this one will go out from my linked list. I hate this. Then I will remove it. And the next will be joined with the other one. And this one will be just omitted. It will be similar with the next also.
Yeah, just find by size number, right? Okay,
Exactly.
thank you.
Okay.
It was very interesting, and yeah, it was just like a gym for our.
Right. Yeah. Yeah, I know it. Okay. I hope that you have learned something and it was something interesting. And I see you next Friday. I hope next Friday I would be more interesting and the people will stay more. Look, we just finished. I finished just with 4 of you. But thank you so much for being here.
Thank
Oh,
you.
Thank you, Mark.
Thank you.
Nice.
Welcome.
Nice.
You
Have a
too.
great
Bye
day.
bye. Bye bye.